I welcome all the viewers to the last, that is the 5th lecture in the series of lectures on Six Sigma. And we will continue this lecture from the yesterday's lecture. We were discussing Defect model. Under this, we covered a lot of things and we will continue with the same. We discussed CTQs, critical to quality aspects of a product or services. We have discussed regarding manufactured products and the services being provided by the vendors. We want the quality in the manufactured products, we want the quality in the service also. For that, we have to identify the things which are required by the customers, and we call them CTQs, critical to quality. And the critical to quality factors can be known only if we discuss with the people who are concerned with the product or the services. And factors responsible for these CTQs we have to identify, and then we have to work on those particular factors. For this, we will discuss further the first and the foremost thing. To know the CTQs or the factors responsible for each CTQ, we will have to have brainstorming session. For brainstorming section, we will call 8 to 10 people who are conversant with the product quality or the service quality. And then we identify important factors responsible for CTQs. After that, conducting a few experimental trials. We will conduct some trials to know the effect and impact of these factors on the critical to quality aspects. Then recognizing significant factors which influence a process. Out of 10-12 factors, we will identify, we will prioritize the factors which are responsible for the critical to quality aspects. And this can be done through collection of data using tools like regression, etc. And after using these tools, we will know what these factors are which are directly corresponding to the critical to quality factors. Setting these factors to get maximum output. Then we will work on these factors so that we get the maximum output from these factors, so that the critical to quality aspect is handled properly and the customers get the maximum satisfaction. And we have to minimize our inputs and we have to maximize our outputs. Under the Defect, now we will discuss improvement phase in the Defect model. And under this Defect model, in the improvement phase, we have to use the following tools. History of design of experiments, and this is called DOE, design of experiments. We may have to have certain designs and experiments, and we will have to implement them and get the results. Say for example, if a chemical process is going on and there are 3 variables, and 3 variables are at 3 different stages to occur. What stages are to be chosen so that we get the maximum yield? So, designs are made for the experiments, experiments are conducted, and the final specifications for these factors are known. And running the process on these specifications, we maximize our yield, and this is done through design of experiments. If we use the experiments without using the concept of design of experiments, we may have to have a number of experiments to be performed. But if we use the concepts of DOE, then we will have to have only few experiments, and then we will be finalizing the specifications for all those variables. Design of experiments, pre-planning, and factors responsible for the yield are to be known. The DOE practical workshop and DOE analysis, and these 3 items are there when we teach the students regarding the design of experiments. Response service methodology is also used for optimization of the process. And lean manufacturing, as we have already discussed lean manufacturing principles. Lean manufacturing is also known as Kanban, JIT, just in time. Here we remove all the fats which are connected with the process, and these fats are like inventory. We do not want any inventory be maintained for the raw materials as well as for the finished products. Any raw material or semi finished product which is required for the process, that should be received before it is required, and it should be delivered at the shop floor where this is going to be processed. It should not be stored in the stores, and this is the meaning of Kanban. And similarly, for the finished product, when the customer requirement comes, immediately we shall be able to produce the product and deliver it to the customer. Nothing should be kept in the stock, and if we keep things in the stock in the form of the raw material, in the form of the semi finished product, or in the form of the finished product, we are adding cost to the manufacturing cost. So, where we have our aim is to reduce the cost as far as possible, and this is done through lean manufacturing. Lean manufacturing, just in time, or Kanban. Kanban is a Japanese term meaning the same thing, lean manufacturing with a small difference. Design of experiments, what can it do for you? Minimum input and the results are maximum. Inputs minimum and the process is there which maximize the yield. This is done through use of design of experiments. And next one is the control phase in the Dumac model. In the control phase, we make use of control charts, because we have to now control the process, what we have designed, what we have aimed at. Now, this process is there which we want that it should give us the maximum results, but it should run in a proper way. For proper running of the process, we use control charts, as we have already discussed control charts which follow the process on timely basis. We have already discussed control charts for attributes, control charts for variables, like we discussed X bar chart and R chart, and these are for variables. We have also discussed P chart, and there are other charts also available like C chart, U chart and NP chart. P chart is percent defective, NP chart is defects, as C chart is also defects, and these kind of charts are used for running the process in the best possible way. Then we have SPC case studies, and under this control phase, to take care of the control phase, we teach the students SPC and with the case studies. We shall be discussing one of the cases in my subsequent slides. Then EWMA, this is exponential weighted moving average. Okay. The meaning of EWMA is explained, and then Pokayoke. Pokayoke is another Japanese term. The meaning is mistake proofing. We produce the product or we manufacture the product so that the product, final product, gives us Pokayoke, mistake proofing. And if we are having a service, we are providing a service to the customer, we make it Pokayoke. Pokayoke means mistake proofing. If anything is done by mistake, then it should not affect the product and it should not affect the service also. Suppose automobiles are designed in such a way that when the driver comes out of the automobile, when it is in running condition, with the same key, with the same ignition key, the door is locked. It means when the driver comes out of the automobile, he is going to lock the car only after switching off the engine, and this is called mistake proofing. And in Japanese term, this is called Pokayoke. 5S techniques we have already discussed. These are part of the control phase, because now we are controlling the process. Reliability testing, we have to maintain certain tests to see the product and to see our services which are being provided to the customer, whether these products or the services are reliable or not. And then business impact assessment, these processes and the results are matching or not. and what is the impact going to be on the business results, whether we are going to get the profits or not by making use of these projects regarding Six Sigma. And this is part of the control phase, and these techniques are taught to the students, and rather these techniques are required to be used in the control phase. And this is one example of SPC, Statistical Process Control, which reduces variability and keeps the process stable. And this is a control chart. Disturbed process, the left one, the chart, the drawing which is shown on the left side, it shows that the process conditions are beyond the upper limit. It means the process is disturbed at this particular point and some action is to be taken. And similarly, on the right hand side, again there are two occasions when the graph is going out of the specifications. The first one, it is going out of the upper control limit, and the second point, it is going below the lower control limit. When it goes beyond the control limits, we can easily say that the process is not running in statistical control. So, we have to do something, we have to see the process, what has made it to run out of control. So, all those things, all those defects will be removed and the process will be continued, so that everything, every reading should remain well within the control limits. And this is the use of SPC, Statistical Process Control. And in the graph, now this shows the natural process, natural boundaries are given by the control limits, and temporary aspects are also shown, and these are temporary offsets which are disturbing the process. Something is getting wrong and that is to be rectified. And the results of SPC, what we get out of SPC? SPC is nothing but statistical process control, an improvement in the process, reduction in variation. Why do we use this control chart? So that we are able to control the variation in the product factor, product specifications. That variation we want to minimize. Better control over the process, we get a better control over the process because it is running continuously, and we have to inspect the process whether it is giving us the good quality product or not. And this good quality product is defined as the product which is under the control limits, upper control limit and lower control limit. Anything goes beyond these control limits is a defective piece. And this SPC also provides practical experience of collecting useful information for analysis. Useful information for analysis is like that. If say 3 or 4 observations are going in one direction, means going maybe close to the upper control limit, and this gives us information that something has gone wrong in the process that is giving points in the same direction, though these are well within the control limits. Then again we will have to see the process, what has made it that all these 3-4 points are going in one direction. Then hopefully some enthusiasm for measurement also. This gives some aggression to the person who is inspecting the process, that it is to be checked on regular basis, and if anything goes wrong, it is to be detected very fast before it produces lot of products of defective quality. Now, we will discuss regarding the projects also. There was a traditional way of looking at the projects, and now there is a Six Sigma way of looking at the projects. What is the difference between the two? We are going to discuss. In traditional, now we used to make an effort, we used to use set of tools, focus on technical knowledge. Project leader is left to his own devices, whatever methods he knows he is going to use, and that was under the traditional method. Results are fuzzy, safe targets are chosen or selected, projects conducted on the site. But in Six Sigma philosophy, we have a difference, and these efforts are made by black belt, and black belt is obliged to achieve financial result. We identify black belt people in the organization, those who are responsible for giving us the financial results. Why financial results? Because we are looking at the bottom line of the results, which makes the company profitable, and these profits are given by the black belts and the master black belts, and these black belts work on the projects, and the projects are prioritized based on the financial results which they are going to give. Higher financial results or the projects which are going to give us higher financial results are implemented first, and the projects which are going to give us lower financial results are handled at a later date. And this is a Six Sigma project selection is a well structured method. There are methods to select the projects which are to be implemented. Focus on experimentation, and a clear focus is kept on the experimentation process. Based on the experiment results, and the projects are implemented. Black belt is coached by champions, champions in the company, sponsors in the company, and the owners of the process. They are there to guide the black belts regarding the projects to be handled and the way the projects are to be handled, and the results are finally quantified. We believe in data, we believe in quantitative results, and if the results are better, we appreciate the use of projects, and this is based only on the bottom line financial results and the quantified results only. It is not like that more or less, it is exact figure, whether it is 10% increase or 9.5% increase. No more or less figures are discussed. Exact financial figures in quantitative terms are discussed. Stretched targets are there. Everyone is given aggressive targets to follow, and aggressive approach is required to follow those aggressive targets. No easy task is given to the black belts or the people working with Six Sigma. Everyone has to go beyond his boundaries and beyond his limits, and the targets are stretched. Targets regarding the time, targets regarding the budget, both are stretched and both are to be met. And the projects are given top priority. Unless these projects are given top priority, financial results will not be visible. Delayed project is of no use, because the results which we are going to get 6 months before and the same results if we get 6 months afterwards, the impact will be less. So, we work on the time bound projects. Now, we will discuss one more model and one more diagram which is very important for the people who use Six Sigma. And this is a basic concept, and it is given to all the persons who are involved in the Six Sigma in an organization. The basic one is green belts. They are also taught this model, and black belts are also taught this model. Master black belts are also master of this process, and this basic thing should be known to everyone who is working in the organization which is using Six Sigma philosophy. And this is SIPOC diagram, and we will now discuss what exactly is meant by SIPOC. SIPOC is an acronym and standing for S stands for supplier or suppliers, I stands for inputs and key requirements. Inputs means whatever things are being input to the process, and those are part of the I. P is nothing but process, O outputs and the key requirements of the customer, C the customer himself, and this makes SIPOC. If we take care of all these aspects of SIPOC, and our Six Sigma will be implemented in a best possible way, and we will get the maximum satisfaction of the customer. How do we define the SIPOC diagram? A SIPOC diagram is a visual representation of a high level process map. Process is mapped in a proper way, and this level of the process map is high level, including suppliers and inputs into the process and outputs and customers of the process, and then finally we get the customer satisfaction. Visually communicates the scope of the project, and this diagram when seen visually will tell us what exactly is required in the system where modifications are possible and we have a better satisfaction of the customers. How can SIPOC be used? What is the method of using SIPOC? SIPOC diagram helps a team and its sponsors agree on project boundaries and scope. This diagram defines the boundaries of the project which is going to be handled, and this also tells us what are the features of the project which is going to be implemented. A SIPOC helps teams verify that inputs match outputs of upstream processes and outputs match inputs of downstream processes. There is upstream process and downstream process. We want that the inputs match outputs and the outputs match inputs of the downstream process. And finally, our aim is to identify the projects and our aim is to satisfy the customer. We want that inputs be minimized and the outputs be maximized with the implementation of any project which is taken under Six Sigma. Now, brainstorming section, brainstorming exercise. How can SIPOC be used in your organization? In this case, people are called, people are given a problem and then they give us certain points, certain suggestions in the form of brainstorming process. How a SIPOC works? And this diagram is formed, diagram is made and it has 5 columns. Each column denotes one factor. First one, suppliers, first letter of the word SIPOC. Inputs, I stands for inputs, process, outputs and the customers. Now, we will begin with the high level process map, and this is going to be the high level process map. We will map the process, how the process keeps on going. There is step 1, step 2, step 3 and step 4, and we have covered 4 steps in this process. And then outputs are also written. Again, we will go back to the process. Here we have identified 4 steps which make the process, which finishes the process, and we get some output. Output is also written. Examples are, we get services, products, reports, metrics or raw data. With the use of process and the outputs what we get are written. And then customers, and who are the customers? Examples are given: internal, external, vendors, end users, management and downstream process. Here a little explanation is required. Customers can be internal customers and can be external customers. When we say internal customer, one process or one step output is the input for the next step. When we say that this is input for the next step is the customer for the previous step, and this is the meaning of internal customers. And of course, external customers who get the products, they are our external customers. Here in this case, we also call vendors as our customers and end users of the product or services our customers, and management, and of course, we have already discussed downstream processes are also our customer, because our product is going to the next process and that next process is our customer. Now, we will go back to the inputs after getting the process, outputs and customers. We have discussed process, outputs and the customers. Now, we will devote some time to the inputs also. What sort of inputs we have given to the process, and these inputs can be in the form of data which has been fed to the process, parts, application, raw materials, and these are certain examples of the inputs which are put into the process. And suppliers. Now, we will discuss regarding the suppliers also, and the suppliers can be internal suppliers, external suppliers, vendors, manufacturers or producers, management and the upstream process. Upstream process, the people who are going to use the product and the people who are going to give us the product, and this product can be in the form of a semi-finished product or in the form of a raw material, and the raw material providers are at the upstream. What is the meaning of upstream and low stream? Upstream is where the raw material is fed into the factory, and low stream is where the finished product is taken out from the factory. Upstream where raw material is used or the semi-finished product are used, and low stream is where we get the finished product out of the factory. If we talk about the different steps in the process, first step is upstream, second step is low stream, and this is the meaning of upstream and the downstream department. Downstream department gets the input from the upstream department, and this diagram is the diagram of SIPOC, and this clearly shows what is the meaning of supplier, who are the suppliers, what are the inputs, and what is the process, how many steps are used and which step is used after which step, and what are the outputs and who are the customers. And based on this diagram, we can find out where the modification is possible, and we will have projects to modify the process at that particular point, and that project will definitely reduce the cost of process or improve the quality of the product, and finally, we will have financial results which are positive in nature and which are liked by everyone. Now, we will have a practical example of the mowing the lawn, and this is the process being used in a company or somebody who is providing service to the customers of mowing the lawn, and what sort of SIPOC diagram will be made in this particular case. We are going to discuss it. Begin with the high level process map. As we have already discussed a general method of using SIPOC, and we will have high level process map for this particular job. First step is prepare lawn for mowing. We will have to remove the stones etc. from the lawn and clearing the lawn and preparing it for mowing, so that the mowing process do not have any difficulty in implementing this first step. Next step, then start mowing the lawn, then finally mow the lawn. After clearing the lawn for mowing, the next step is mow the lawn, and then final trimming will have to be done in the lawn, and then third step is trim the lawn, and finally clean up and removal. And these four steps are part of the process of mowing the lawn. I will repeat. First one is prepare lawn for mowing, mow the lawn, trim the lawn, clean up and removal, and this is the process, complete process of mowing the lawn. Outputs, what sort of outputs we get? We get debris from the lawn, beautiful lawn. Finally, we have a beautiful lawn which is properly mowed, and bagged grass clippings. The first one, debris from the lawn, whatever stones etc. are found during preparation of the lawn for mowing, that is collected separately as debris from the lawn. And result of mowing the lawn is a beautiful lawn, and also we will have bagged grass clippings. Whatever cuttings are there from the grass, those will be collected in the bags, and these are the outputs of the process of mowing the lawn. And then output is also their happy customer. We will have a happy customer. And next one is customers, homeowners. Homeowner, the owner of the lawn, is the customer for which we are giving the service of mowing the lawn. Your yard waste recycler. Recycler is going to take the debris and recycler is going to take the grass cuttings. And now, what sort of inputs are there? And this we are going to complete the SIPOC diagram. As far as inputs are concerned, we have long lawn, a lawn with grass, and the lawn is long also, and this is our input to the process. And then we are also going to use the lawn mower, means the machine who is going to cut the grass, and that is the input to the process of lawn mowing. And the trimmer for trimming the lawn, and trimmer is also used, and that is going to be the input. And the gasoline for running the lawn mower, okay? Gasoline, petrol, diesel, and these are the things which are used for running the engine, which is fixed on the lawn mower. And then yard waste bags for collecting the grass cuttings, and that is the input. And these all inputs are there for this particular process. And rake and broom is also used for collecting the grass cuttings, collecting the debris, cutting the stone pieces or collecting the stone pieces, and these are all inputs to the process of lawn mowing. Now we get suppliers. Who is the supplier? Homeowner, who is going to supply us the lawn for mowing. Home Depot again is a supplier, and Chevron again is a supplier. And now this completes the exercise and of preparing the SIPOC diagram. Now we plan brainstorm a planned project in your organization, and this exercise is for the viewers, and they can plan a brainstorming session in their own organization for any sort of problem, and they should collect the data regarding CTQs, details of the project, details of the inputs, details of the customer, details of the outputs, and details of the suppliers, and then they should complete the SIPOC diagram, and they will come to know what practical difficulties are there in preparing the SIPOC diagram. Here again you will have to begin with the high level process, may keep 4 to 5 process steps only. I am repeating the same process, how to draw the SIPOC diagram. Maybe process covers step 1, step 2, step 3 and step 4. And list process outputs, list key output requirements, and this is part of the outputs. And then list of customers, who are the customers, maybe internal customers and external customers, and those are to be listed in the column where customers are mentioned. And then we will go back to inputs, list process inputs, what sort of inputs are to be there, and list key input requirements, and finally list suppliers. And this completes the SIPOC diagram. This is an exercise for the viewers. They have to go back to their individual organizations, take up a process and complete this SIPOC diagram using the steps the way I have told to prepare this diagram. And looking at the diagram, you will come to know that where exactly an improvement is required or improvement is possible, where exactly modification is possible, and then brainstorm. And this brainstorming is also done for knowing the suppliers, knowing the inputs, knowing the process details, outputs and the customers. This completes the SIPOC diagram, how to prepare the SIPOC diagram. And now we will discuss certain things which are related with the Six Sigma. One item is there, Kaizens. Kaizen is nothing but small improvement which is carried out in the organization by the person who is working on the process, and he suggests something regarding the process to make it more effective, more profitable and more safe, and those suggestions are known as Kaizens. It is a Japanese term. Kaizen was created in Japan following World War II The word Kaizen means continuous improvement. It comes from the Chinese characters Kai, which means change or to correct, and Zen, which means good. Making a change for good, making a change for improvement, making a change for profitability, making a change for making the process safe, and this is the meaning of Kaizen. And in the organizations, people encourage workers, employees to give more and more Kaizens, and then the employees are awarded for providing the Kaizens, because Kaizens are going to improve the process, improve the profitability, and the profits are shared among the employees. Kaizen is nothing but continuous improvement process. Some modification is made and it is seen stabilized for some time, another modification is made on the process. With this result, we go on getting the continual improvement of the process, and focus on gradual and continuous improvement is made. Whole business philosophy is used, importance of everyone buying into the concept and the vision. Here we say that everyone is involved in the process of continual improvement. Unless everyone is involved, our results will not be 100% perfect. To get the 100% perfect results, involvement of everyone is required. Now, we will review what so far we have discussed, and we will also review what are the things which we have left. And this is going to be overview of the first 4 lectures also. Six Sigma relies heavily on advanced statistical methods. Six Sigma philosophy is based only on statistical methods. Statistical methods, they are used, data collection, data presentation, representation, use of statistical tools, implementing them, making a change in the process, looking at the results, making minor changes in the process, and finally implementing the projects. And this is the meaning of Six Sigma methodology. It is a new way of doing business, though it is a new way of doing the business, but it is very effective also. It is a new way of doing business that would eliminate the existing defects efficiently and would prevent defects from occurring again and again. This prevents defects to occur, and this is the meaning of Six Sigma methodology. Where can Six Sigma be applied? We will discuss now. It can be applied in production. Six Sigma methods can be used in production. These can be used in design also. Six Sigma philosophy can be used in design. We have already discussed house of quality, quality function deployment. This tool is used in designing the product, and the product goes to the customer with shortest possible time if we use the quality function deployment, if we use the concept of house of quality. In service industry also Six Sigma methods are used. Purchase also Six Sigma methods are used. HRM, human resource management, also uses Six Sigma philosophy. Administration also uses Six Sigma models. Quality department, of course, is the best user of Six Sigma philosophy. Management, top management also uses Six Sigma methods. M&S also uses Six Sigma methods. IT also uses Six Sigma methods. All the functional areas in the organization make use of Six Sigma methods. Six Sigma companies, now we will discuss something about Six Sigma companies. Companies who have successfully adopted Six Sigma strategies include Black & Decker, GE Global Research, Motorola, of course, started with Six Sigma, Sony, and these are few companies who have made use of Six Sigma and are benefited with the use of Six Sigma philosophy. Now, we will discuss certain barriers to implementation of Six Sigma models and Six Sigma philosophy. Barrier number 1, the most important barrier, which should be taken care of. Engineers and managers are not interested in mathematical statistics. Engineers and the management people working in the organization, they are not interested in using mathematics in the organization. People are not aware of mathematical techniques and statistical techniques, and this is going to be the first barrier in the implementation of Six Sigma models. Barrier number 2, statisticians have problems communicating with managers and engineers. Statisticians who have mastery in statistics, they are not able to communicate properly with the managers and the engineers who do not have grasp of statistical tools. It becomes difficult in explaining the concepts of statistics to the people who do not know about statistics. This is a barrier number 2, and this is for implementation of Six Sigma, and it should be properly taken care of. How can it be taken care of? This is only by educating managers, educating engineers on the tools of statistics. Barrier number 3, non-statisticians experience statistical anxiety, which has to be minimized before learning can take place. There is an anxiety among the people who do not know the statistics, because Six Sigma uses only statistical tools, and if somebody is not aware of statistical tools, he will be afraid of working in the organization where Six Sigma philosophy is being used, which is full of statistics and statistical tools. So, only thing we can do is we can educate people, we can train people on the statistical methods, and this can be done in continuation with other training programs. Next barrier is barrier number 4. Statistical methods need to be matched to management style and organizational culture. There are 2 things which are there in the organization. One is management style, style of management working, and the culture of the organization, and these 2 are there which are fixed in the company, and the statistical tools which are going to be used for implementing Six Sigma should match with the management style and organizational culture. If these 2 are matching, only then Six Sigma philosophy implementation will be effective and possible. Six Sigma reasons for success. The success at Motorola, GE and Allied Signal has been attributed to what? Strong leadership. Jack Welch, Larry Bossidy and Bob Galvin personally got involved in Six Sigma activities to take their organizations to the highest level. Initial focus on operations, they put the initial focus on the operations to implement Six Sigma and get the results. Aggressive project selection, I have already discussed aggressive project selection, aggressive follow up and aggressive targets, and this is part of Six Sigma philosophy. Potential savings in cost of poor quality, and this is $50,000 per year. It is not a less amount. If just maintaining Six Sigma activity, if we are able to save money, then it is good for the company, good for the organization. And then training the right people. These people, what they have done, they have trained the people in their organization on the Six Sigma activities. As I have already discussed, this requires statistical tools, this requires certain models to be understood, this requires certain measurement techniques to be understood, and this requires certain calculations to be understood. If this is possible, then the organization can make use of Six Sigma philosophy and Six Sigma models in the organization, in the company. The right way, plan for quick wins, find good initial projects and fast wins, and in Six Sigma we look at the bottom figure, bottom line, which is the profit. Establish resource structure, make sure you know where it is. Publicize success, often and continually blow that trumpet, and it should be known to everyone that Six Sigma philosophy has given us the good results. Embed the skills, everyone owns success is everyone owns the responsibility. Only then Six Sigma implementation is possible. Some facts about the Six Sigma. We'll discuss some facts. Okay, this should be known to the viewers also, and this is part of the Green Belt course also. Bill Smith, Motorola engineer 1929 to 1993, is the father of Six Sigma. So, Bill Smith is known as father of Six Sigma. He is the person who introduced Six Sigma philosophy, and it started in Motorola. GE's Jack Welch made it central focus of his business strategy in 1995, and he got the results, and those results were enormous. Michael Harry is called the godfather of Six Sigma. And this particular word, Six Sigma, coined by Motorola engineer Bill Smith. Bill Smith gave the name Six Sigma. Now, a major influence on production methods and quality assurance. Now, this is a major tool for improving the quality and implementation of the projects. Data and statistical driven. This concept is only data driven, fact driven, and based on statistical tools and data and statistical driven approach to eliminate defects in production. And this aims to improve processes and reduce variations in the quality. And it also necessitates organizational change, training and planning. Zero defect. Defect, as we have already discussed, any product or service that does not conform to the set standards or satisfaction of the customer, and we want to make it zero. Six Sigma is a concept that tries to achieve a near zero defect with 3.4 defects in a million event. This we have already discussed. We are reviewing the course which has been covered so far. Early adopters include Bank of America, Caterpillar, Honeywell International, previously known as Allied Signal, Raytheon, Merrill Lynch and General Electric. These are the companies which have made use of Six Sigma and have got the enormous results as far as their profits are concerned, as far as their reduction of the wastage are concerned. Six Sigma, it is a methodology to improve business process by constantly reviewing, updating and retuning the existing process. Six Sigma improves the process performance, decreases variation and maintains consistent quality of the process output. This leads to defect reduction, defect less service and defect less product, and improvement in profits, employee morale, product quality and finally customer satisfaction. And this is part of only Six Sigma. Six Sigma strives for perfection, zero defects, and it allows only 3.4 defects per million opportunities for each product or service transaction. Six Sigma relies heavily on statistical techniques to reduce defects and measure quality. We will devote some time on the evolution of Six Sigma. Japan has been credited with the evolvement of quality systems like TQM, we have already discussed, Kanban, Kaizen, etc. Pioneered in US by Bill Smith at Motorola. Bill Smith, father of Six Sigma in 1986, originally used as a metric for measuring defects, for improving quality, a methodology to reduce defects levels to less than 3.4 defects per million opportunities, and Motorola has saved $17 billion in 2006 just by using Six Sigma philosophy. Early adopters we have already discussed: Bank of America, Caterpillar, Honeywell International, and previously it was known as Allied Signal, Raytheon, Merrill Lynch and General Electric. Six Sigma was originally centered around manufacturing activities only. Manufacturing activities means the products only. Now it has gone to the service industry also. Reason for this is knowledge of the statistical tools in the manufacturing industry functions was more, and it was easy with which we can quantify the benefits. and now the same benefits are being seen in the service industry also. And we have also discussed sigma levels in our previous lectures. The Greek letter sigma represents one standard deviation from the normal or average. The higher the sigma level, better the quality level of the product or the service. If we have 1 sigma, 2 sigma, 3 sigma, we will say 3 sigma is better than 1 sigma. Similarly, 6 sigma is better than 4 sigma. And sigma levels also we have already discussed. 6 sigma says that only 3.4 defects per million, and similarly 1 sigma shows that 6,90,000 defects per million opportunities, and so 1, 2, 3, 4, 5, 6. 3 levels of 6 sigma are there: metric, methodology, and management system. 6 sigma is a registered service mark and trademark of Motorola Incorporation. Metric, the term sigma is often used as a scale for level of goodness of quality. Equates to 3.4 defects per million opportunities. 6 sigma started as a defect reduction effort or a process in manufacturing and was then applied to other business processes for the same purpose. Methodology, we have discussed metric. Methodology, business improvement methodology that focuses on organization, understanding and managing customer requirement. CTQs, critical to quality, aligning key business processes to achieve those critical to quality requirements, utilizing rigorous data analysis to minimize variation in those processes, driving rapid and sustainable improvement to business processes. This is part of methodology. And we have also discussed DUMEC, define, measure, analyze, improve and control. This is a cycle, this is a model. And then define opportunity, measure performance, analyze opportunity, improve performance and control performance. This is part of the DUMEC model, which is given by 6 sigma philosophy. And this is also different aspects of DUMEC philosophy and different things which are under define, which are under measure, which are under analysis, which is under improve and control are given here. Now, we will discuss the third part, which is management system, which is given by 6 sigma. Top down solution to help organization. It is a top down process. Align their business strategies to critical improvement efforts. Mobilize teams to attack high impact projects. Accelerate improved business results and govern efforts to ensure improvements are sustained. Finally, we want that the projects be handled and those projects be handled which give us the profitability. Framework to prioritize resources for projects that will improve the metrics, and it leverages leaders who will manage the efforts for rapid, sustainable and improved business results. We want improvement in business results all the time, and only those projects will be implemented which improve the business results. Levels of 6 sigma implementation. Here already we have discussed 6 sigma champions, green belts, black belts, meaning of black belts etc. we have already discussed. Black belts are also known as agents of 6 sigma in any organization, and master black belts. These are the people who conduct 6 sigma training and also have on the job training and experience. Some 6 sigma tools, we have already discussed QC tools, 7 QC tools, we introduce certain other tools also. We will just enumerate those tools again. QFD, quality function deployment, which was house of quality. Cause and effect diagram, we have already discussed, fishbone diagram or Ishikawa diagram. Failure mode effect analysis, FMEA, and then t-test of the statistics. This test helps 6 sigma teams validate test results using small sample sizes, which are less than 35 in number. We use t-test of statistics, and this was Guinness Brewery is the work environment that led to W.S. Gossett's creation of the t-test, and t-test was created by W.S. Gossett of Guinness Brewery, and now everyone is using this t-test. Control charts we have discussed in depth. There are certain other charts also available. Viewers can study them on their own. Design of experiments, and this completes the today's lecture on Six Sigma. And I feel amply awarded if viewers are able to understand Six Sigma philosophy and Six Sigma tools, also the meaning of Six Sigma, selection of projects, and the models what we have discussed, DUMEC, SIPOC, tools we have discussed, and I'll feel very happy if the viewers are able to concentrate and viewers are able to understand the philosophy which was behind Six Sigma. And I hope that they will make use of these lectures in their day-to-day work. Also, they will use these concepts in the organizations where they are working, and they will also use these concepts for training other people also. Thank you so much, viewers.